Okay, so we are into part two of our journey learning about objects and drilling down and um, kind of getting underneath the hood a little bit. So let's go on and pick up with where we left off yesterday, and that's on Boolean objects. So if you remember when we discussed objects and we looked at those tables and whatnot, we could recognize that the Boolean object is actually a wrapper for the Boolean primitive type. Encapsulating primitives and objects might seem a little bit silly to you, but sometimes it can be really useful. In a few units down the road, we're going to look at ways to define new methods and properties for these wrapper objects that can be useful to us. But for now, we're just going to go ahead and look at the predefined members of that Boolean object. Sound good? All right, so we look at it, the Boolean object defines no properties, and there are only two methods that this object has, and that's the toString method and value_of method. So the thing that you need to do is be careful not to be confused about the fact that with objects and functions, for example, we have this object, say a variable called x is assigned the value of true. We've seen this before, where we have b equals Boolean x. Well, this script here creates a primitive Boolean named b, but it doesn't create a Boolean wrapper object. And the reason why it doesn't do that is because there's no new keyword. All right, so you need to keep that in mind. In order to create that Boolean wrapper object, you need to have the new keyword. So the call to conversion function Boolean has nothing to do with that Boolean wrapper object. The correct script for creating this Boolean wrapper would be as follows. So we have x equals true, assign the Boolean value, and where we have the new keyword utilized in our b reference, variable reference. So we have b equals new Boolean x. Using x as the argument, the new keyword creates this Boolean wrapper. So let's take a look at the Boolean toString method. So this method returns a string that contains either a true or false depending on the value contained by the Boolean object. So this is best represented by this example. Go ahead and put this example into Flash right now, and let's take a look to see what this looks like. Okay, so what's going on here? First of all, we're creating a new object reference, okay? And the reference would be, of course, b, right? And then we're assigning it a new Boolean instance that's initialized to a value of true. So we have the new keyword. We're creating this new instance here, and the value is true, okay? Then we're going to trace both b, and we're going to use the method, the type of method for this argument b, all right? So we're going to trace out the value, the actual b value, and to see what type of method it's going to be. So these outputs would show like true and object, respectively. After that, then we call the toString method. So you can see this method is being called down here on b, okay? And then we conclude by tracing both s and the type of s. And so they would also yield true and string as well. So let's go and see if that exactly is what our output is. And you'll see as I run it, you'll see exactly we get true object and then true string. Now, that's got to be exciting. So let's take a look at this value of. Method. So this function is going to return a Boolean primitive that contains the same value as a Boolean wrapper. So when you use a Boolean where a Boolean primitive is required, Flash automatically calls this value of the Boolean for you. And again, this is best illustrated with an example. So go ahead and put this example into Flash right now. So here's the deal. This might seem kind of weird to you. And you may be wondering, like, okay, well, why would you use this function? Because you're simply just referring to this Boolean, and it gives you the same result. But you think of it like this. All right. When you use a Boolean where a Boolean primitive is required, Flash will automatically call value of on the Boolean for you. So if we look at this script where we have b equals new Boolean, true, and we say if b, in a circumstance like this, in this situation, we're using a Boolean inside a conditional if statement. And that's the same as doing the following. Now, for this reason, we'll probably never ever call the value of function on a Boolean ourselves. We'll just go ahead and let Flash call it for us. But in a circumstance like this, we're using a Boolean inside this conditional if statement. So just understand that that's what's going on. Okay? So this isn't going to run, or we're not tracing anything else. So just put this example in and keep it in there for your notes to show me that you actually kind of have an idea as to what's going on with this. Okay? So let's move forward and let's go ahead and take a look at the number object. And I'll try to go through this pretty quickly for you because this really does get kind of lengthy. The number object, that basically wraps the primitive number type just like the Boolean wrapper for a Boolean primitive variables. And in addition to this, the two methods and one property present on Boolean, the number object defines several more properties. And so that's an important thing to understand here as well. So for example, we have in our number object, we have a property called the max value property. And what this does is it represents the largest number that Flash has ability to store. And so you can kind of see the scientific notation here indicating that, hey, that's a pretty big number. You can see the number followed by, what, 294 zeros? That's huge. Doubtful that you'll ever have that many aliens coming in and attacking you all at the same time. So just thought I'd let you be aware of that. Then we have the infinity constant. It's actually a number. And so if you put this bit of code in, trace type of infinity, why don't you go ahead and do that right now and see what the result might be. So you can see by the compiled result here is that the type of infinity is actually indeed a number. So we want to look at infinity as represented as a number as well. Okay, so another way to refer to the value of infinity is to use the property number dot positive underscore infinity. And here's another example. You can go ahead and put this in Flash right now, trace number dot positive infinity to see what the result would be. You see, Flash has two versions of the same number because the value of infinity came before ActionScript actually changed over to meet the ECMA standard for object-oriented programming. So because the ECMA requires the number object and its positive infinity property, these were added way back when Flash released version 5. But the original infinity constant still remains from the previous versions. Both versions of Infinity are really the same thing, and as you can see by, if you run this script, you'll see that the result will be show the same result. So we could jump over to Flash and run it, and you'll see that in fact it does indeed return Infinity as well. So I just kind of wanted to clear that up. It's kind of seems like a moot point, but it is a good FYI if you invent some older script. Okay, so we have an example of the positive infinity property where we can show that the number is actually a positive infinity. And then in the same way, we have a let me go to the next slide here. We have a number minimum value property. So this property is really similar to number.max value, except that it finds the smallest possible number that can be stored in or represented in Flash, or with the number that is the closest to 0, if you will. So and here's the actual value in scientific notation. In other words, it's about 300 zeros. Okay, so it's a pretty small number as well. We have a negative infinity property. Again, it's similar to positive infinity, and that's represented by this. You can see the trace statement, how it's used. You can put that into Flash as well. And then we have a NaN property. Now, while we're on this subject of numbers, we should talk about the way Flash tells you that something is actually not a number. If you try to do some mathematical calculations, say like on a string, Flash is going to respond a globally defined constant called NaN, and that's what it uses to represent things that you ask for as a number, but that Flash just really can't convert into a number for you. So similar to this relationship, infinity and number, positive infinity, there's no relationship between the global constant, not a number, and .NaN. So you can see this by looking at some script here. So let's go ahead and jump over to Flash. I put those some examples here for you to kind of see. Let's go ahead and run them out. I'll go ahead and compile it. So you can see in the first case scenario, I've got where we have trace number.positive infinity. Our result is actually infinity. In the second case, I've traced out our negative infinity value, and it comes up with a negative sign in front of infinity. And in the third case, I traced out number.NaN, and you can see the result is actually not a number. Okay, so hopefully this makes some sense. I know a lot of this seems a little bit trite for you, but it's important to understand when you get some erroneous errors or and you test your code in the output field, and you'll know why this is happening. Okay, so the final wrapper class that we have to really discuss here about in ActionScript is our string wrapper, and as you may guess here, the string, this actually wraps the string primitive. Okay, so it works very similar to the number in Boolean. The single property that string defines is called length. So the string object defines several methods for us, and so we can take a gander or take a peek at some of these methods and best served through some examples. So here's a list of methods that are compiled in a table here, and here's the name of the method and a description of what this method basically is. And so we'll take a look at all these, and we'll try to work through them quickly, and you can read through them if you'd like, pause this and take a view of it to kind of get a window or a view as to what's ahead here in these slides. So all those methods in that previous table, they're really useful for text processing. So we need to really take a look at them, especially if we have text-based games or text used in our games in any way, shape, or form. So let's take a look at the one here called the string.charAt method. So it's logical to think about a string as an array of characters. Strings, they contain a contiguous block of variables. You know what I mean by contiguous? Contiguous means like one follows the other, okay, in a continuous string. So all strings are indexed from 0 to length -1. And then the charAt method works by accepting an index as an argument and return the character that exists in the index location. Think of it this way. Strings are a lot like arrays. In a way, so they have that, what I call the contiguous block of variables, right? So the arrays, actually, they're used as an implementation, if you think about it this way, of strings in most programming languages. So it's logical to think about a string as an array of characters. Okay? So the charAt method works by accepting an index as an argument and returns the character that exists in that index location. And so it has actually the form. Hopefully you can see it at the bottom of the slide. I'll see if perhaps I can even highlight it. Let's see. I'll do it this way. Use my highlighter. And, oh, that's not working. Okay. Let's see if we can fix that up a little bit. Okay, so finally I was able to bring that syntax up. This is the syntax for the string.charAt method. So I've got a string, my string dot, whatever string I want to call it, dot charAt on an index. All right. So what is this really doing? Well, you can try to look at this at first and say, well, this function returns a string primitive. And the reason that that happens is because there's no character type in ActionScript. Instead, a string primitive, you see, is return containing the single character that occurs at the index given as an argument. So notice here that the function is shown to be called on my string, and that's because the string object is not global, if you remember that table. So instead what we do is we call it on an instance of the object, and I've got an example of this script. So we can go ahead and put that in Flash. So let's take a look at the exact example. So go ahead and type this into Flash and take a moment to do that. So as you can see here, what we're doing is we're first creating a new string named S, and we're handing the string a value of hello, okay, in quotes. So we can see that that's clearly a text string, and we're handing that to the constructor. So this is the argument that's being handed to the, we know it's a constructor, a new object, because it's a new string type object, and here's a constructor, okay? And our variable reference is S, okay? Then what we're doing is we're looping with a for loop using the S length property, okay, as our index for our loop. Okay, so in other words, remember when we looked at the for loop, you've seen this quite often. Here's our initialization, here's the evaluation, what we're evaluating, and here's our iteration here, all right? So we're evaluating that I is less than the length property of S, okay? And then we're going to increment I. Okay, the I being our control variable. So we're looping S length property as our loop index, and inside the loop, we're going to trace one character, the one at the loop index's position. So essentially, it's going to print the string vertically in our output window with one character on each line. Let's go ahead and compile it and see what happens. And indeed, it does do that. Check it out. Pretty nifty, huh? I told you you'd get some excitement in this class. This is it. So here's a method that's kind of fun. It's called the string char code at method. And basically, it's a function that's going to return a 16-bit representation of the character at any given index. So it's going to give you a number with the ASCII representation of that character. Go ahead and put this example in Flash and see what you come up with here. So here's our ASCII representation for each letter. So in the word hello, this would represent the H. This would be the E. Here's the 2L position in the ASCII character set, and here's the O position. Pretty groovy, I must say. I know it's an old word, but I'm old. That's okay. Okay, so this thing might be a little bit confusing. So let me go ahead and try to explain what's going on here with this particular one. This one's called the string.from char code method. Even though the string object is an instance object and you call methods on instances of it, not all of these methods of every instant object work that way. So the string.from char code is an example, perfect example of this. So this function is not called on an instance of a string object. Instead, it's called on the global string object. And so we can look at the form of this. This is our actual form of the syntax. And you can see that the function returns a primitive string, and it's not capitalized. And it's called on the global string object. So the following script right here, this right down here, this shows an example really of the use of the string.from char code. Okay, go ahead and put that in right now and see what that does for you in Flash. When you compile it, you should see the word hello, because we're just, this is the ASCII representation of that string that we just discovered on the previous example. And so when I put use from char code, basically it'll trace out that word or that representation. Okay, so just notice that the way the global string object is used when we're calling the from char code method. This function is used if you have several ASCII codes and you want to convert them into a string. Okay, here's another method. It's called the concat method, meaning concatenation. I think I've used that word before with you guys, but concatenation just means to combine stuff. It's a fancy word. In fact, you can impress all of your friends just by using that word. It rolls off your tongue very nicely, and you'll definitely not only impress your friends, but you'll really appear really intelligent. So that's a great word to remember. But here it is used in the method. It's string.concat method. So this method works by accepting a second string as its argument and copying that argument on the end of the first string. So the string that concat was called on. okay, is just added onto that. So then the newly created string is what is returned. So here's the syntax right here, and again, this is best shown as an example. It's not destructive, so the original string remains intact. You're not going to alter it at all. So let's take a look at an example of how it works. Go ahead and put this code right into Flash to see what the outcome is going to be. So having done that, let's go ahead and compile it and take a look and see what the end result is. You can see in the first case, when we traced out s.concat on t, we get the result of hello world. Okay, so I'm taking the s object, and concatenating it with string t. And then in the second trace statement, I'm using s and concatenating string m, t, m, t, s, s. And that's how I got the rest of this message. Hello, mom, I'm home, world, mom, I'm home, world, hello, hello. Kind of exciting. It's kind of a little bit of trickery with code, so it's kind of fun. We're, essentially, for you guys who may have a hard time to follow this area right here is we're just creating 3 strings, and then I'm just simply calling concat a couple of times to get that output. Pretty cool, huh? Okay, here's a method that searches for a string for a specified substring. An index is given, and then a search begins there. All right, so then the method returns the index of the first occurrence of that substring, which has this following general form: number, my string, index of, substring, start index. There's 3 examples. I can put all these examples into Flash now, and let's take a look and try to figure out what's happening. As you do that, I'll try to explain what's going on here. I'll jump over to this one, and I'll go ahead and compile it and run it so we can see what's happening. Looks like I've got an error of some sort. Boy, I hate those syntax errors, so I fixed it up here in my code. Hopefully you can copy what I had here. Your output should be, what I did is I was lacking this parenthesis, the end parenthesis, and I forgot to comment out my example single line comments. Anyway, you see the best of the best. They always make mistakes as well. So in any case, when I compile this, you can see that the output is 6, 12, and -1 respectively. So let's look at each of these methods here and how they're being used. So the script's output is 6 in the first instance, because the string's index begins at 0, and the substring world first occurs at the 7th character, or index 6. Look at the second example where a starting index is being used. So this script's output would be 12. And again, the search doesn't begin, in this case, until index 3, which means that the first occurrence of world is skipped, and then the first occurrence after the starting index is at the 13th character, or at index 12. And then if you look at the final example here, where the substring doesn't exist in the string what at all, this example, the substring Fred, this guy here, all right, does not exist in the original string, so the number -1 would be returned. Okay, so that's why that's the answer for, or the logic behind this code. So that's going to be it for this section 2. We still have a few more things to discuss yet on strings, and we definitely will do that. We just looked at the index out. We're going to look at the last index out method in the next session, slice. Then we'll look at substring methods, split methods, all in having to do with string, how we can set strings and send strings to lowercase. That could be really, really important. And then we'll look at other types of objects like date and function. There's function call methods, different methods associated with functions. And then the object, of course, and object instantiation. An important part that we'll talk about in the next unit will be movie objects as well. So there's still a lot more to talk in these sessions. I just wanted to keep them to about a half an hour so that you can take a break in between or what have you. So until next time, I'll be signing off, and we'll see you for part 3.